There are those who claim Earth is a flat disk with the Arctic in the center and Antarctica with its Great Wall of Ice around the rim. Some say government entities guard this ice wall to hide our flatness. Others say it's not the shape they're hiding, but rather the truth about the space program. That in reality, it was all a sham and that no one actually went into space to take a look at our planet. So if everyone is lying, how do we know Earth isn't flat? Well, we do have pictures, like this one, and quite a few more. But if these photos are all doctored, falsified, and/or tampered with, what are some other methods we can rely upon to help us determine the shape of our planet? First, the classics, the stick and shadow. Back in the day, Eratosthenes noticed that if you stick a rod into the ground at two different locations sufficiently far apart, the length of the shadow they cast are different. And since the sun is so far away its rays are almost parallel to each other, he concluded that Earth must be round. This was proof enough for the classical thinkers, so it should be good enough for us, right? But what if the sun is so much closer than it actually is, and the rays from it are nowhere close to being parallel? Never mind that we would all burn. Wouldn't the closer sun also explain different shadow lengths? Let's try another method, ships. If you live near a coast, go find and watch a large ship sail off into the distance. The taller, the better. If Earth were flat, the ship would just get smaller and smaller as it sails away, until it becomes impossible to see with the naked eye. However, in reality, you'll notice that it gets smaller and smaller until the bottom of the ship starts to disappear into the ocean, as if it's sinking. But no worries. All it's doing is hiding behind the curvature of our beloved planet. This should be proof enough that our world is round, and many would agree. However, what if this is the result of some kind of unknown optical illusion? What do we do now? Hopefully method number 3, the existence of time zones, is more convincing. If we all lived on a flat disk, the sun would either be up or down for everyone. This can be easily verified. Just call up a few friends who live abroad and check to see if they all see the sun or not. I'll bet some of your friends will report the sun is just rising, while others report it's high in the sky or that the moon took its place. This can only happen if we live on a spinning sphere and the sun shines on one side while the other side hides from it. This should convince even the most skeptical, but let's say for example that the sun has the capability of directing its rays only on specific regions of the disk while rotating above it. Kind of like how stage spotlights can illuminate just the stage while the audience watch in the dark. If we can accept that light from a rotating sun can somehow selectively shine only on certain areas below it, and unlike an audience of a play noticing the spotlights and their effects, that this phenomena cannot be observed elsewhere, wouldn't that allow our flat Earth to have regular time zones as well? I think it's time to bring out the big guns. The fourth method, gravity. Gravity is the force that pulls stuff towards each other. To be specific, toward the center of mass. So simply by having gravity, a flat Earth is not possible. Gravity will pull on the outer parts until things are nice and round. This is why celestial objects we see in the sky are spherical. But for the sake of argument, let's assume a flat Earth with gravity is possible. Unlike a round Earth, where the center of mass is always below you wherever you stand, on a flat Earth, gravity pulls you down only at the center of the disk. And as you move away from the center, gravity will pull at you from an angle. The more you move away, the steeper the angle. As a consequence, water will flow towards the center, trees will grow away from it in order to stay upright, and walking towards the edge will feel like an uphill hike, even though the ground is flat. Is this what you observe around you? Probably not. Unless you're in the center of the disk, which would be the Arctic according to the flat Earth map, a quick glance of your surroundings and a brisk walk around the neighborhood should tell you you live in a round planet, not a flat one. Thank you, gravity. But what if gravity itself is an illusion and our flat Earth is actually accelerating upward at 9.81 meters per second? Wouldn't this also explain what we observe whenever we drop an object and let it fall to the ground? So conundrum solved, right? Except if Earth continues to accelerate upward so we can drop stuff downward, At some point, Earth will have to move upward faster than the speed of light, which we know cannot happen. So until we actually develop warp drives, proving speed surpassing that of light is possible, it might be wise to stick with the round Earth approach. But to be honest with you guys, I'd rather live on a flat disk if it means we can have warp drives. Seriously. Stick size.